So my name is Sheehan, and this is my co-presenter, Murali. We work at State Street. We're engineers there. If you haven't heard of State Street, it's the world's largest custodian bank with about 10% of the world's assets under custody. So basically, we're responsible for kind of the safekeeping and transfer of assets around the world. If you trade a stock, for example, chances are it goes through one of our systems. So it makes for a lot of interesting blockchain use cases, and that's what we do there. We're not going to be talking about State Street specifically today, but we're going to be talking about chain code development practices. I want to thank you for attending our session. I know you had some others to choose from, so we'll try and make it worth your while. If there's something that we don't cover, a question we don't get to, something you want to know about, we'll be around for the rest of the conference, so please find us and chat with us. So this is the plan of our talk. We're going to do a bit of an introduction, and then we're going to cover 7 chain code topics. The astute observer may note that we originally said we'd do 5, but we couldn't keep ourselves to 5. We would have done more if we had more time. And then we'll go through some final thoughts and questions. And we've kind of ordered this from like very introductory topics to more advanced topics. So hopefully there's kind of something for everybody in the audience. So the kind of goal of this talk is to prevent this comic on the right side. Often when building software, you think that you're going to start out and do things perfectly, and then you kind of get bit by these things you don't know much later down the line. Murali and I share some of the blame for the original chain code interface, and I'm sure if we could turn back the clock to 2015, we'd make some changes. So we're going to try and kind of make you aware of things that you should know before you start developing chain code. Features that you should consider as your use case evolves, potential anti-patterns you should avoid. And we originally called this talk Chain Code Best Practices, and we decided to just change it to Chain Code Development Practices because we wanted to stress that this is based on our personal experiences. You may have found something different works better for you, and if you did, we'd love to know about it and chat about it. So diving in, let's talk about the chain code interface. So this is the interface that I'm sure everyone is very familiar with. We have the init and invoke functions that we'll talk about, and then we'll talk about the functions for getting arguments from the client. There's a lot more to the chain code interface, but we're just going to stick with this basic part for the beginning. So the first kind of anti-pattern we want to talk about, and this is one of our developers on my team asked us to include this in our slides, is to not initialize global variables in the init function. If you're new to chain code, it may not be clear when that init function gets called. A lot of people automatically assume that it's kind of similar to the lowercase I going init function. It's not. This was just a poor naming choice we made many years ago. The init function is only called when the chain code is initialized on the peer, right? So if your peer joins the network at a later time, it's not going to be called. If the Docker container restarts, it's not going to be called. So if you initialize something here, if you initialize a global variable, it may look like it works in your testing. It may work in your test environment. You may find it doesn't work later on. So the thing to do is if you're going to store any stateful data, you should, and this kind of makes sense, always use the fabric state. Don't try and do something like this. The next thing we want to talk about is don't rely on the raw interface. So this is for getting the arguments from clients. The first functions here are these get function and parameters and get string args API. This works well for demos, but it doesn't give you a well-defined schema. And when you're developing chain code, you don't want to get in that kind of that tunnel mode where you're just thinking about yourself or your organization. You always want to be thinking about what it's going to be like when you're in a multi-organization world, right? When you don't have full control over your schema. How are you going to make those updates? How are you going to deal with clients which may be using an older version of your schema to talk to the chain code? So those functions, if you use them, it'll be very hard to evolve. You should be using the get args API, but use it carefully. Consider using something like protocol buffers to serialize your data. Fabric uses these very heavily. And it'll kind of give you that built-in way to evolve your schema over time and deal with clients at an older version. And we'll talk about this more later. The best thing you can do, though, is use tooling that abstracts that raw interface, right? A lot of people have thought a lot more about this problem than we did when that schema was originally written, and they've done a better job of abstracting it, right? These tools will give you a formal schema definition. They'll allow it to evolve over time, and they'll get rid of that awkward invoke function. They'll allow it to essentially seem like the client is calling functions inside of the chain code, which will make your programming model a lot better. Some of the tooling that I've listed here, Hyperledger Composer. I put a question mark next to that one because I know IBM said they weren't going to be working on it anymore, but hoping the community will pick up some of that. There's an improved programming model coming in Fabric 1.4 for Node.js, which will make it look more like you're calling functions in your chain code, so that's something to use if you use Node.js. At State Street, we use a tool for, called Hyperledger Chaintool, which helps you develop Go chain code. It works really well for us, and it's part of the Hyperledger ecosystem. There are a number of proprietary solutions you can use, and then my final suggestion is write your own. I think it's not that difficult to abstract the raw interface, and I also think this is a major gap in Fabric still, and it'd kind of be it'd be a really good Hyperledger project or contribution if someone really wanted to put time into it. So this is briefly how Chaintool works. I'm not saying that Chaintool is the end-all be-all, it's just what we use, but this is kind of like how some of these tools work. They basically allow you to define a schema, which you'll see over here. It looks very much like protobuf syntax. The only difference is we also have functions in there. And then that schema will essentially generate code that's used both by your chain code and your client. And this kind of gives you that magic where like a client may have an older version of the schema, but still work with your chain code. Because once you're in a multi-party network where there are multiple organizations, you're never going to get everyone to upgrade all their clients at once. It's going to be impossible. It's hard enough to get agreement on upgrading the chain code, right? So you really need clients to be able to work with the older, or older clients to be able to work with newer chain code versions. So let's talk about the development lifecycle next. So this is what I call like the I'm excited to try Fabric pattern, right? When someone's new to Fabric, the very first thing they do is they install it on their laptop. They write a chain code, they deploy it to Fabric, and then they test it in Fabric. And you know, the maintainers of Fabric have actually made this pretty easy and straightforward at this point with scripts to do a lot of this for you. The problem is there's just a lot of overhead, right? And deploying to Fabric and testing in Fabric, right? And you don't want to be stuck with that overhead every day, so you don't want to get trapped in that loop. Because the only thing you really want to focus on, you know, if you're really writing production chain code, is writing the chain code, obviously. You don't want to be bogged down by Fabric every day. So the thing to do here is just be aware of these mocks that exist in Fabric. They're already there, they work great. So you can just write your chain code and then unit test it using mocks like you would for a lot of your other, you know, development activities, right? And this will give you that rapid iteration and instant feedback and make it very easy to do chain code development. In my day-to-day development, when I'm writing chain code, I do not spin up a Fabric instance every day. It's not necessary. Eventually, you'll need to do integration testing. You know, like I said, try to avoid requiring all your developers to install a Fabric instance. It's one of those things that'll start out easy, And you may not even, if you're the first person to install it, you may not realize how complex it's become as you write more and more. But as soon as you onboard that new developer and try and get them to configure their Fabric instance, it'll be very difficult. There is a dev mode that you should look into if you do need to test in Fabric, because not everything is mocked. And that will give you fairly rapid iteration in Fabric. And then, and this is just kind of standard development, but we have a CI environment where we have Helm charts that deploy Fabric for us into Kubernetes. So everyone has the same configuration, and we get out of that kind of it only works on my machine scenario. Transaction collisions. So this is something that's very important to understand before you start developing with Fabric. These typically occur when you have a use case where you're trying to track a balance with some constraint. The most common example is, I have a bank balance, and it can't go below $0, or you're tracking an inventory. We also see this with complex objects. And the reason you need to understand this is because it's the kind of thing that will not happen in your development environment and your test environment. You may only see it when you go out into production. And I feel bad because every once in a while I see someone on the mailing list say, hey, I've been developing this chain code for 3 months and now I've just discovered this problem. So know about it on day one. I put a picture of the Fabric architecture up here so you can go into more detail and understand it. But the thing to understand here is that there are these endorsers, right, that endorse your transaction. It's sent back to the client and then sent to the ordering service where it ends up in the committer, right? And during that process, your transactions may end up out of order. Other transactions from other clients may come through, right? So you don't have guarantee over kind of the order of your transactions. So if we look into the state to see how this happens, there are lots of ways to interact with the Fabric state, but the primary functions are these get state and put state functions. Get state takes a key, put state takes a key and value, obviously. The thing to know is that inside Fabric, there's this third value, a version. And for the sake of simplicity, we'll just say it's an incrementing number, right? And each time we write to the state, we're going to increment that version. So when you send your transaction to the endorser, it generates these read sets and write sets. So if we have this simple, get state, put state, where we're going to get the balance and then put a balance of 50, we're going to generate a read set with balance and we read version 3, and a write set where we write balance and we write a value 50 to it. And what's going to be written by the committer is a balance of 50, and now we're at version 4 because we've changed the value. I'm curious, this is a little quiz. If we put in a second get state where we get the balance again after putting 50, does anyone know what that returns? Yep, yeah, exactly. Yeah, Fabric does not support read your own write, so it'll still return 100. So this is just one of those little gotchas when writing chain code. So we're not going to generate a second read set for that. So what are these collisions, right? So we have this example here where we have 2 transactions, right? The first transaction is going to try and subtract 50 from the balance. So we're going to get the balance to check that it's over 50, and then we're going to put 50 to the balance and generate our read set, write set, where we read version 3, and then we eventually write version 4. And at that same time, we're going to have a second transaction come in. Again, this will get the balance. We're going to subtract 75 this time, so we're going to make sure the balance is over 75. We're going to put 25, subtracting that 75 from 100. And we're going to generate a very similar read set and write set. So the problem is only if both of these transactions are endorsed at the same time, only one is going to make it through at the commit level, because one's going to write a version 4 and the other is going to try to read version 3, which we no longer have. We're not at that version, and that transaction's going to be rejected. So how do we avoid this problem? Well, there are several ways. First, if you just completely avoid, duplicate keys, you don't reuse keys, you won't have this problem if you have a new key for everything. So for example, you can store your balance in deltas. It makes it difficult, right, if you're trying to track a constraint on every delta change, but you can periodically reconcile them in the chain code. You can look into the Bitcoin UTXO format that kind of pushes key management to the client. The problem is then you send the difficulty to the client, so they have to deal with this problem now. You can consider kind of trying to break up your hotspots, right? So if we had kind of owner in a balance, maybe we'd want to change our key to owner and income source in a balance. And that way, right, if we were updating things at the same time, but they weren't always from the same income source, we wouldn't run into these issues. And then we're working on solutions in Fabric. We have this enhanced concurrency control design, which will hopefully make it out in 2.0 or soon after 2.0, which are kind of some low-level ways to try and solve this problem. And then hopefully people will build upon that in the future. So next I'm going to turn it over to Murali for Chaincode Data Modeling.
Thank you. Yeah, I thought this is better than hanging something on my neck. So I'm Murali. So like we said, we are trying to organize it such that we will take off from where he left. So, so we talked a little bit about collations, right? Transaction collations and so on. That leads us right into, and Sheehan briefly touched upon, how do you organize your keys and so on to make sure that you don't have, or reduce or minimize the collation chances, right? That leads us plumb spang into data modeling, right? So what I will do is I'll organize this rest of this talk into data modeling, visibility considerations, right? All of them are part of how do you organize your transaction and data so that you can, cater to the blockchain considerations of chain code. All right, data modeling, right? So typically what happens is this. You have a typical three-tier model, right? You have the users, you have the SDK-driven application talking to the fabric, and then eventually the data is sent for commit and so on. This is what happens. So there is this notion of original data, whatever it may be, something the user entered on the website, maybe. And then that gets transformed by the SDK in some form, or passed us, and then eventually call chain code invoke for various transactions, and so on and so forth. The real question is, chain code intentionally exposes a simple args byte API, and the idea is you, the developer, can control whatever you want using that API. What about these args? How do I organize my chain code to use these args? Two important considerations for that. One is the format of the args, and then the representation of the args, right? And you will please keep in mind as you talk about that original problem of how do you avoid transaction collisions, etc., as you go through this. Okay, args. I have two options basically: convert in the SDK tier or convert in the chain code. Which should I use? The real question is. Some of the questions are, do I really need to change the data? Can I keep the data in its original form? Remember, we are talking about format only, not the representation. And is it better to keep the data in one form to avoid conversion, efficiency? Is native format. By native format, I mean, you're writing the language in, let's say, Golang, right? And then you want to use Golang protobufs. For me, the native format, the convenient format would be protobuf in Golang. Is that better for manipulation? I want to change something. I want to access some data. It is often more convenient to access it in the native interfaces than something external. However, we also have to keep in mind, it's always, if you can, typically good practice to keep it in the original form, if that's the form that you're going to be using and accessing often. But most often, you do want to change stuff. You do want to inject new data. You do want to manipulate things. And we will see a little bit more on representation as to how all these things can get real tricky. But from a pure format point of view, right, you want to note that there are some formats better than the other. And to me, my favorite is protobuf always for a couple of reasons. One, like we talked about, it's easier to handle native format. But more importantly, protobuf allow the versioning properties of protobuf help to reduce churn and migration upgrade. Assume this scenario. You return a chain code, you deployed it to an organization structure of 10 organizations, each running the chain code. Now, something happens and you want to extend the chain code, you want to add a new field, right? Now, there are two options. You deploy, you make the change, and have everybody upgrade to that new chain code at the same time, or things won't work. Or you organize your chain code in such a manner, you develop your chain code and application in such a manner to allow for such extensions of such changes, and you control those changes using protobuf's versioning properties. So in other words, the linchpin, the main point of how you organize your chain code is basically to think about it from a data level, and the facilities like what protobuf offers you to be able to extend your language. So what will happen? You made a change, you added a new field to your data, you deployed it, and then you are able to deploy it to only one chain code, other chain codes are still running. You send the new data to that chain code with the extra field, and you send the same data to other chain codes also with the same extra field. The other chain codes will continue to work because protobuf will just suppress those fields, and you will, because you organized your application and the chain code for such extensibility, you do not have to upgrade the chain code at the same time. This is a very subtle point, right? And this goes to the heart of why choosing the right format is so important, because some formats allow you to do things like this. Some formats don't. Let's talk a little, now we come back to just format. Format, what did we mean? JSON versus protobuf, for example. Or keep the whole native, just web-based format, whatever you receive in one form, right? Those are the choices. Representation, what is it? Let's recap a little bit here. First of all chain code data is based on key value pairs. Keys are not encrypted, but value can be, if you want to. And every get put access is an access, every put is a trip to the ledger. You need to, every time you do a get or a put, you go and make a ledger call across processes. Okay, so this is the basis with which we start with, and this is the differentiator of chain code versus other normal applications, right? You have to deal with this set of constraints. One more set of constraint that we are not talking about here is that this chain code is running on multi-party system, and so everybody is going to be accessing it at the same time, which you talked about. All right, let's take a look at what do we mean by representation, right? A couple of quick examples. A simple car parts key value representation option. Okay, I'm going to represent everything in the car with a car ID, and I'm going to treat the parts as blob, right? Let's say blob is basically JSON structure, whatever. The other option would be to break up this into multiple key value pairs: car engine parts, car body parts, car ID, dashboard parts, so on. What's the advantage is one versus the other, right? In one case, the only key you had, the first case, the only key you had is car ID. So every time you want to, get the car, you are going to go to the data ledger and present the car ID and get all the data at once, whether you want to use parts of it or not, number one. Number two, you are going to have to deal with deconstructing the parts yourself, right? But still, there may be cases where you want to do that, whereas the second option actually lets you leave the job of interpreting the data, if I can say that, to the ledger itself. So you can say, given the car engine, give me just engine parts, or give me just the body parts. So which choice would you use, right? It depends upon things like data access frequency. How are you organizing a chain code? Are you organizing your invoke calls for different transactions which say, for example, I want to allow somebody to get all the engine parts only. That's a transaction. Or I want somebody to modify something in the body parts. That's another. If you're going to organize a chain code like that, obviously having the separate car engine, separating it into fine-grained key value pairs makes more sense, right? Collision avoidance. Let us say that we talked a little bit about this, and now if we are going to have one car ID parts blob, and you're going to have multiple transactions accessing the data to change it, obviously every transaction is going to change the same car ID key and modify the value somewhere else. One transaction may be modifying the engine parts, another may be modifying the dashboard parts, in which case you're going to have collision, and you're going to, if your application needs to have multiple transactions, you need to think about the way the transactions are accessed, the way the data is accessed for those transactions, and organize your data accordingly. And then the other thing is the direct ledger query capabilities. So the more fine-grained you make your key value pairs, the better you'll be able to use the ledger capabilities directly for accessing data. The last thing is, like we said, keys are not encrypted. So in one part, in the first example, all I know is there's a car ID. In the second example, I know more things about the car. I know perhaps the engine ID. I know various things. So the more key value pairs you have, the more you reveal about the application to somebody else. So bringing it all together, so you can put all the data into few key value pair, keys and values, and there are pros and cons to that. So if you have few keys and values, you will make fewer round-trip ledgers to the fetch the data, reveal less about the data stored on the ledger. The cons are transaction hotspot, right? Everything is stored into fewer things, and so more transactions will access these things. And then application data is not apparent. You know only about few key IDs, and everything else is the actual semantics of the application is stuffed into the values. Iteration searching could be inefficient because you fetch the data and you iterate through it, as opposed to using Fabric facilities for doing all that. Splitting into several keys, pretty much the opposite of all this. The pros are reduce the transaction collisions, and you have fine-grained access to the query and querying capabilities. The cons, obviously, more round trips to the ledger, and you're revealing more about data due to key proliferation. I'm not going to read through this. This is something you could access and use later. But if you're using CouchDB, as you probably are, there are some interesting things about you need to keep in mind for accessing. For example, I'll just read one bullet item. You create the CouchDB indexes in the Chaincode package. So when you create the chain code, you can say, and you're using CouchDB, you can say, these are the indexes I want you to create when you instantiate the chain for this particular CouchDB. Another interesting thing is the phantom reads. When you're doing range queries and composite keys, as they get validated, so you are in the chain code. You did a range query. You did a whole bunch of stuff. And then you're going, at the commit time, you're going to commit that transaction. Now, in that range, you might have come across some other transaction might have come and changed that range. So the range you read is no longer valid at commit time because some other transaction came and injected something else. This is automatically validated for you by Fabric, and it will abort that transaction because it will know what a read set is. So you need to avail that, and you need to model accordingly. So the next thing we'll talk about is visibility. So we are now graduating from data to the actual channel organization from a privacy and confidentiality point of view. You can read this, but let me quickly go through the key points here. That is a network of four organizations, and there are two channels, one in black, one in red. And there is just one chain code, which is shared across all four channels. And there is also in dotted line private data channel for channel Y. I didn't mean to do that. sorry about that. Okay. And then this is the network organization. On the left, we have actual transactions coming through. So a proposal is sent to the query chain code, and the transaction is sent for ordering by two organizations B and C. Given that scenario, what are the visibility considerations, right? I'm going to organize my channel and chain code architecture. And these are the high-level things that we know about that will constrain what our channel structure should be. Recap, right? The chain code input is sent to endorsing peers. The output from the chain code is sent for ordering to peers for commitment. And the most importantly, the input and output are visible to the entire channel, not just the output. Even the input is visible. Whatever you send is actually part of the transaction that is sent to the ledger. So given that, what types of visibility you want? Do you want all channel members to see all the transactions? Do you want only some organizations within a channel to see some of the data that's flowing through? And then finally, so these are at the channel level. But even at the individual transaction level, what kind of access control do I want? Do I want somebody to send some data and some others not to be able to access the data? So these are all the visibility and access considerations that we have. Let's take the first one, the channel level separation. The key fact being data is isolated between channels. So let's say that we have this chain code and there's a key value pair, channel A and channel B. The data that's sent on channel A, let's say you send an invoke to channel A, to the chain code on the channel A, and you save the data. That data is not visible to channel B. So if you can organize your application and separate them in such a way that you do not need these common data to be visible across chain codes, then that's a prime candidate for channel level separation. And the question you would ask is, application can be modeled on the basis of channel grouping. If the answer is that, yes, data isolation is fine, I can applications do not have to see data between two channels, then that's a prime candidate for that. So, but in reality, you typically do end up having applications need to access having common data. For example, in a simple insurance application, the name and the identification of the person is common, and it is shared between different channels. And so you would try to organize your chain code application in such that you will take the common data, which can be visible to everybody else, and put it on a channel on its own, and then have other channels access it via chain code to chain code call. So visibility consideration within a channel. So now here, the key fact being transactions and state is available to all members of the channel. You have only one channel. Everybody can see the data and transactions. So question is, does the data need to be visible only to a subset of the orgs? The transactions are visible to everybody, but do I need to have some private conversation with somebody else, two peers, two organizations who can see the data but others cannot? So the use of the private data in Fabric will facilitate that. So what would you need to do? Specify the private data. There's a notion of collection of private data and who can access it and the policies for accessing the collection data. You need to specify that instantiation time. So at the time of setting the chain code, instantiating the chain code, specify the collection parameters. And so for that channel, and the chain code, you will have restrictions on who can access this private collection. And you will use the private data APIs to access that. In addition to, as a bonus for allowing only certain members, certain organizations to see this private data, you can also have the additional bonus of the transaction being, the data being invisible across the whole entire network through the orderer. A quick talk, now we are talking about the access control inside the chain code. So first we talked about the data level separation, channel level separation. Now access within the transaction, fine-grained access control. So if you look at, there are the config policies that are defined in the Fabric that allows that control access to chain code. And these two in particular is probably what you're going to look at. And these are controls that can access any chain code in a channel. So these are not about accessing any particular chain code, but this is what the peer exercises to control who can access any chain code in the channel, right? So the question you need to ask is that enough? I have a channel, I have some chain codes in a channel, and the policies I can define in the fabric, are they enough to, is that all I need? And I do not need any more fine-grained access to control access to a particular chain code in a channel. If the answer is yes, you can stop right there. You can just use these knobs to control the access, do the access control. But on the other hand, if you do need fine-grained access control, this is not yet well documented, but this can be done. None of these policies and resource management that you see for defining access control, they are not specific to the peer. They can be, with some difficulty, used for controlling access to chain code as well. So you write your own chain code. And you want to say only so-and-so can access this chain code. And some others cannot. Using the same fabric mechanisms. Not X509 certificate inside chain code, but the policy-based mechanism that Fabric provides. You can do that. So how you do it? You would add your own resource, just like what you see here. You will write your own policy, and you will exercise that policy by doing this follows. You will create an access specific to ACL specific to the chain code. I keep doing this. Add your own resource, and then access them in plugins. So the Fabric has a notion of creating your own filters and plugins, which are not well known, I think. So but they are easy to use once you do know how to use them. So you will write your own plugins, and this plugin actually acts as a filter. When a proposal comes into the peer, this plugin gets called, and you can define the plugin to be called, and the controller will pass to the plugin, and you can actually use this policy and resource mechanism to control access to chain code. You can say, this proposal is for my chain code, and there is a policy defined to it. In this plugin, you can look at the proposal header and see if that it's got the credential satisfies the policies and allow access or not. Finally, now that we are talking about plugins and policies and so on, we don't have to stop there. There is a lot more you can do by way of dynamic injection. What is dynamic injection? You have a chain, yes?
So can I just,
yes.
do you have a question afterwards?
Afterwards would be, just as soon as the talk is done, we can talk.
Okay.
That's right? Yeah. So, what is dynamic injection? You have a chain code, and you're sending data to it. And the data comes from the user, and it can be modified by the SDK, but beyond that, nothing modifies data today, right? But let us say you do want to modify data. What are some use cases? I want to be able to inject some data in the peer. Let us say I have organized my chain code to have a database URL. Each peer, each organization has got their own databases, all right? This is something you don't want to do. You typically access external sources, but if you know the rules, you can break them, right? So let us say you do want to access your external data and each individual organization, right? The database URL is probably not available to the SDK or the user, but something at the control of the organization. I want to inject that. How do I do that? So you would, once again, use a plugin. And in that plugin, there is something called a decorator. You can look it up in the documentation. I think it's in one of the slides here. There is a notion of a decorator, and you can organize your plugin to say, take this data and put it in this decorator, which will be passed to the chain code. The chain code has got an API for decorators, and in your chain code, you can access this decorator data, and then you can modify it accordingly. In other words, in your peer, you can say, my peer is pointing to this database. Use the database. This data did not come from the SDK. This data did not come from the end user. This data was injected by the peer. The other popular, no, I shouldn't say popular, the other commonly talked about use case is the use of the transient field. This is another field in the proposal that you remember, right? All parts of input and output are seen by everybody and stored in the ledger. You do want to say, for some reason, I do not want to send this data, right, back to the for commitment. You can put the data in the transient field. It will be in the input. It will be seen by the chain code, and the chain code can access it, do what it wants with it, and then it will never be sent to the orderer, or it will never be sent to the for commitment. What this means is, if you can organize this for, you can send cryptographic material for doing some encryption, decryption, things like that in a controlled manner. So once again, all this information is there if you know where to look for it in the Fabric documentation. I have some pointers here, and we can also talk about it in soon. That pretty much brings us to the end of this presentation. And so basically, let's briefly go through this. We can create a schema for transaction. Always think about how we'll put upgrade in a multi-party network. Running a Fabric installation locally is not always necessary for day-to-day chain code development. We talked about it at the beginning. How do you organize your life cycle, and what the best practices are. And the key point in the middle was talking about transaction collations, right? And that's something that led us into how to organize your data, how do you organize your channel information for privacy, and then we talked a little bit on expanding on some internal details of how to use plugins and access control mechanisms present in Fabric. That's all we had.
You were talking about access control mechanisms, and I know that if you use Hyperledger Composer, they have a notion of role-based access control for certain chain code functions. Do I have to model it as different chain codes then, if I want to have access control for specific functions in my chain code, or is it possible with outside configuration on the same set of chain code?
So a couple of things. There are two mechanisms at a little higher level, two main mechanisms for access control. What we talked about was trying to use Fabric's inbuilt mechanisms, MSPs, policies, all those things directly, and have it run by Fabric directly for you, and you will use special purpose chain code plugins to access that. That's one mechanism. And the advantage of that mechanism is you already provisioned identities and policies upfront along with the rest of the organization. The other mechanism is using the standard X509 certificates and attributes in them to enable access control. I'm not sure about this, but I think Composer might be using that kind of mechanism where it will generate code and it will take from you credentials and exercise and say, if this happens, I need access control. For this method invocation, I need this access control, right? That's the second form of this thing. These two are completely separate, as you can imagine. Now, if you're first of all, does that answer part of the question at least?
So they would also check it in. So they would check in a plugin for like a
No, they
certificate,
don't.
Or?
They don't.
Okay.
They don't. So this plugin mechanism is something that is available to you if you want to make use of the Fabric's mechanisms for doing stuff, right? The other mechanism, which I did not have time to talk about, is actually going into details of the X451. That is actually a library called CID in Fabric, for example, with the Go plugin, which you can use to. So when a proposal comes to the chain code, it contains a lot of credential information. Who sent the proposal, right? You can actually extract information from that, and there's a library to help you extract information, and you can do access control based on that. There's already an example in the Fabric called ENCCC example or something like that. I can point you to later, but which will tell you how to use that. I have a feeling that the Composer will generate something like that rather than this mechanism we talked about. Sure. Yes.
how would you advise to integrate Fabric Network with like a NoSQL database for saving XML file or this kind of stuff? Would you create like a channel-specific chain code with a specific policy, or have you already think about that process yet, or?
So let me make sure I understand the question first. When you say saving data in a NoSQL database, you are talking data separate from the ledger, not the key value pair, but your own data, right? I think that's a very big topic in and of itself, right? That's a very big topic. We would want to do it for many, many different reasons, obviously, right? And in a, but your question was more related to access control in that scenario, correct? How do you do access control in that scenario?
No, it was more broad scope for if you... It was a more broad scope, like how would you save file? I mean, you would save the hash in the ledger, and then how would you, what kind of system would you implement to save the files?
Right. If so there are two parts to that question. One is why we are doing that thing. So that one very good reason for saving in a separate database, maybe just that the data is too big. I don't want to store 1 gig of data in my Hyperledger Fabric, so I want to keep it there, right? And in which case, the other reason would be, I do not want the data to be visible to others, right? One is size, other is visibility. Both are good reasons for storing in that. In that case, I think typically the answer would be yes. You take a hash of it because you do want to know the provenance and you want to make sure the data integrity, aspects of the data is guaranteed. So you will take a hash of that and save it into the ledger, and you will take the private data and put it onto your MongoDB or NoSQL DB or whatever, using one of the APIs. The tricky part would be that if you're going to send this transactions to, if you're going to send the proposal to multiple peers, all of them are going to be saving on their own data.
That's why I was saying creating that is why I was thinking about creating a channel-specific upload channel or a similar process.
Yeah, you will probably create a channel-specific implementation for that, and you will have only that particular channel save the data, and nobody else would.
And would you handle the connection to that database in the chain code or in the front end, or what would you advise?
You should have to come generate from the chain code. So the proposal is received by the chain code, and the chain code has a logic to exercise that proposal. It's not going to delegate that responsibility of doing that to somebody else, right? So you have only two options. Either do it in the SDK, right? Or do it in the chain code. If you do it in the SDK, how do you guarantee that the hash has not been changed, right? So there are many things. This is a very, but this is something people run into all the time, I'm sure. But the thing is, there is no one good right answer. Sorry. Yeah. Yes.
Hi. Thank you for the very interesting presentation so far. You've described something about separating the data structures on a concern based on how they would be modified by transactions. Are you suggesting some kind of compositional model if you have some persistent data set like a JSON that is composed of smaller data sets with some references, if I understood correctly? Could you go a bit deeper in that? Can you give maybe some example or?
In general, every data has got structure, right? I mean, the user data has always got some structure most of the times, unless it's some JPEG or something like that. The idea with the composition was to do exactly what you said. Separate the data into different representational composition, but based on access patterns, right? what is getting accessed. So let's say you have an iteration of parts, right? One JSON structure, and it's actually has an array of 10,000 things, right? You have two options. You can either put the JSON structure as 10,000 as one blob, in which case you have to retrieve it and iterate through it. The problem with that approach is whenever you retrieve the data, you have all the data or none of the data. But whereas if you had a separate key value pair for only that data, now you have the option of iterating through that. Now you can say, you can use the Chaincode API to iterate through the data, and you can stop when you got the data you wanted. So the goal there was, I don't think we can come up with a generic policy of how to structure the data. It differs, very application dependent, but the fact that we do have to structure the data and you have to separate into key value pairs based on access patterns and based on other considerations like collations, different peers and different organizations accessing at the same time will become very important there.
Yeah,
okay,
this is like a pattern I find myself writing over and over again. So I do think it's like someone could write some type of development tool to make it better. Because like I said, we define our messages in protobuf. So, at a very high level, I have an account and that person owns a lot of stocks, right? And there are various, when you own a stock, there may be like, oh, you have trades in flight, you have some that are pending, right? So there are all sorts of different values that we store. And yeah, it's like at the client level, we kind of have this object that represents it. And deep down in the chain code, yeah, we do it where we break it into a whole bunch of keys, right? Based on those access patterns Murali was talking about. And then kind of build them up in the chain code to return what appears to be that single object. So yeah, it is something that we do. It's hard to have like a generic answer for it because it's very dependent on your data. But if someone thought about kind of a way to do that generically, it would be very useful.
And also the key is to do it all early in the process because late is too late typically.
Yeah, if I am allowed to come with the second question, then it comes again an interesting point how you can resolve a rich query scheme. Sorry, how you can perform then rich queries, for example, on CouchDB where your JSON data structure is broken into different objects. You have to keep maybe the references for let's say the parent objects and the child objects on both sides. So you can query from top to bottom and from bottom up, if you understand what I mean.
So this is CouchDB specific rich query.
Yeah. But this is again the only if we go level DB, you cannot make any rich queries. The only chance is with Couch, so that's why I'm referring on it.
So I'm trying to understand the question still. So basically we will talk later because I don't want to say something that doesn't answer your question.
So one more question. We don't have the concept of gas in Fabric. So how we can limit the amount of execution steps in a chain code?
Oh, you cannot. That's a simple answer. Today, there is no notion of gas or amount of resource that the chain code can or cannot execute.
So you can have an infinite loop and break the system.
It doesn't have anything like that. And that's, the blanket answer for all that is you're in a permission network where you come together and you deploy the chain code with understanding that everybody knows, right? So that's the blanket answer for that. Anything else?
Thank you.
Thank you.